In this example, we need to find the arc length of this curve given by this parametric equation and the range of t between 0 and 1. So we will apply the formula directly for the arc length, which is integral from a to b square root of each derivative square, which means I will take the x prime, y prime, and z prime, as we did in calculus 1, how we find the derivative. So this will be a big integral from a to b. We have big square root, and now we have 3 terms. I need to find their derivative. Let's go them one by one. The first one, I have square root of t. So if you do the derivative, this will end up with only square root of 2, because derivative of t is 1. You end up with this one. The second one is our favorite, because et, the derivative will just stay the same as et. And the third one will be just negative e negative t. And those are the derivatives. The next step, we have square upon each of these. So I will get 2 plus e 2t plus e negative 2t. Remember, this negative will go away with the square that is there. Now, usually when we have a questions about arc length and we end up with 3 terms, 1, 2, 3, most of the time we should suspect that those are complete square. Why we should suspect this? Because there is square root and we want to cancel the square root and the square. So we suspect that there will be a complete square. Let's see if our suspicion is correct or not. And here I will do it just from 0 to 1. Remember, this is the derivative from 0 to 1. So I get 0 to 1. I have big square root. Now this is my suspicion, is that something square is sitting here. Now we ask ourselves, how do we expand a plus b square? What we need to do, we will get a square plus b square plus 2ab in the middle. Now, you can see that this is e2t, so most probably this will be et, because when you square it, you will get this back. So this is my suspicion. I'm trying now to check if my answer is correct. So this is et. Plus, again, I see that I have e negative 2t, so if there was e negative t, this will give me this back when I square it. Let's try put this one here. All is good, so far so good. However, we need to check if our answer is correct. Let's do it. Now, if we do the first one square, that's correct. If we do the second one square, that's correct. Now we need to do 2 times first, which is this one, times second, which is this one. Now this one equal e 2e t negative t, which is just 2e power 0, which is just 2, and that is 2. So my suspicion is correct. That's how we check if our answer is correct, and that's how we make it as a complete square. Now, why did I do this? Square root with square, the next step would be just an easy step, because they will cancel each other. So you will get integral from 0 to 1. If they cancel each other, I will just end up with this one and negative this one. Again, I'm back to the usual one variable calculus. I can do the integral directly. Et is et. The other one will be negative e negative t, and the integral from 0 to 1. Now, if you substitute 1, you get e1 minus e negative 1. Minus, if you substitute 0, this will be 0, which is the final answer would be e minus e to the power of 1. So, in this example, my curve C is given to me as an intersection between 2 curves. This is the first curve, and this is the second curve. So if we compare this question with the questions before, I don't have x in terms of t or y in terms of t or z in terms of t, so I need to find them first. I need to find the parametric equation. So we need to find the parametric equation of the curve of intersection. Now, what is the parametric equation for the curve of intersection? It means we need to solve the system of equations. So we have a system of equations, we need to solve them. Now, what's the system of equations? It is x squared equal to y. This is equation number 1. Equation number 2, 3z equal to xy. Now, there is something we have noticed in this system. It has 2 equations with 3 variables. And that is not something we always would like it to be. So the idea we do here is one of the variable, I will just write it down here. One of the variable will be a free variable, and we will call it t. Now, which one to be a free variable? We choose x to be equal to t. Now, if we do it quickly here, if I put instead of xt, from this equation, I will know that y equal t squared over 2, which is directly can give me the value for the y. So the value for the y will be y equal t squared over 2. And the reason why? Because x is t, take 2 to the other side, we get t squared over 2. Similarly, if we want to find z, this x will be t, this y will be t squared over 2, and this 3 will go down here, so the answer will be 6 down, and here I have t squared with t, I will get t cubed over 6. So here I have z equal t power 3 over 6, and those are the parametric equation for the curve. Now I'm back to where I started, finding the arc length of the curve. What we are going to do next we need to find the range of t I have from the origin to this point. So just go to the next page and we'll continue. So we have solution. We need to find the range of t. How do we need to find the range of t? We need to compare. I have the origin, which is 0, 0, 0. So what I will do, I will compare my x equal to t to be equal the 0, which is from the origin. That means t equal to 0, because there is nothing actually I need to do. It's directly t equal to 0. And then I will do the same thing. I'll compare x equal to t with my other x from the other point, which is 6, 18, 36. Remember, we can choose x, we can choose y to compare y with y, we can choose z with z. The easiest one is to compare x with x. So the x in my equation with the x of my origin. I get this. The x of my equation, which is t, with the 6 from the other point that is given to me. And now we are back to find the arc length. Remember the arc length. Before I do the arc length, let me just rewrite down everything we did so far. So, in summary, we have x equal t, comma, y equal t squared over 2, comma, z equal t3 over 6, and the t between 0 and 6. Now, I'll take this one, because I will use it to find the arc length. So we'll just go to the next page and we'll do the arc length. Now what is the arc length? L equal integral from 0 to 6, because t is between 0 and 6, big square root dt. Inside each one of these square roots, I need to write the derivative of x, derivative of y, derivative of z. If you remember, x was t, so the derivative of x is 1. Y was t squared over 2, so the derivative will be just t. And for the z, it was t cubed over 6. So if you do the derivative, it will be 3t squared over 6, which means it will be 2 squared over 2. Now we expand this square, so we get big square root. This will be 1 plus t squared plus t power 4 over 4 dt. Again, as we saw before, if we have 3 terms, my suspicion will be that this is a complete square. So let's try if this could be a complete square. And if it's a complete square, it will be easier for us to deal with. So complete square means I have to write it like this. And remember, complete square means it should be a squared plus 2ab plus b squared. Now, how we are going to guess it? I know that this one could be t squared over 2. Because if you square it, you will get this back. 1 is 1. Because if you square it, you will get 1 back. So let me try this guess or this idea here. So I will do 2 squared over 2. Now we have to check our answer. Let's check our answer. 1 squared is here. Good. If we square this one, we get t4 over 4. So far, so good. Now, if we do 2 times the first one times the second one, we get t squared, which is exactly the one in the middle. So again, it's there. I'm happy because the square root will just cancel with this one. So I will get 1 plus t squared over 2 dt. Now this is integral t plus t power 3 over 6 from 0 to 6. If we substitute 0, we get nothing. If we substitute 6, this will be 6 plus 36. The answer should be 42, and that's the answer for the arc length.